Hi, good morning. Today we are going to talk about Git. Git is a very useful tool for doing version control. I think a lot of you might already familiar with Git, but the concept behind the Git is quite complicated because the design of the Git command is a little bit messy, and it is kind of difficult to derive the logic behind the command of the Git, because I don't think there is a clear logic that you can invert from the command name of the Git. There are a lot of like a pull, merge, or maybe like push, commit, a lot of different things, but most of them, the name comes from some historical reasons. However, there do have some logic behind the Git branching. So we are going to, the primary goal today is that we're going to introduce the logic behind the Git branching. We're going to use this website. As you can see here, this website. This website contains a series of practice and exercise that you are going to take, and in fact, doing the simple task and exercise in this website is the homework of this course. We have 3 weeks of this mini course. We only have one homework, that is this the practice in this website. I'm going to do the first several rounds of the exercise and show you how it is. And after you have done this, you are going to have some check mark on all of these things. So I'm going to ask you to have all these check marks done on the main part, and I encourage you to do the remote things. I probably will just show you like just a few of these exercises, not all of them, but plenty enough. So at least you're going to try to solve some of them. So for the homework, you are going to take a screenshot of this image of completion, or complete the text, and with something that identify that this is you are doing, showing like a Gmail or like other login, or just do something to like a signature or anything. If you don't know how to choose, just use your school Gmail login as part of here. Just shrink the window and put your Gmail account here. So just that we can identify this is you. This is not a very strict check to prevent you from like cheating or not doing it. It's just a simple reminder, so that, because taking a screenshot is so easy. So it is so easy that you ask somebody else to, okay, I didn't finish it, so can you give me your screenshot so I can submit to E3? All I want is just to prevent you to do the easy thing. But most of you, most of the part still need you to finish this job by yourself, to ask yourself to do the thing. So I'm just doing the minimum so that to encourage you to finish all these tasks. But before we do this text, I'm going to do a demonstration of many of them and some of the remote things. But before that, just to be complete, I will run the command line of git to show how the git actually works. Although I'm just going to show some basic operations. And I'm going to show you some website that I think is useful for you to learn things. Okay, so the main website we are going to use is this learn branching. So we're going to visit a little bit later. And this is also another learn and practice Git website, so that you can try here. But we are not going to use this website as our homework. I'm just let you know there are more exercises that you can have on this website, and they sort of cover different topics. So it is still interesting and useful, even if you have already finished the first one. This is a median of different workflow. Because Git is a tool, but people using it in different way. So there are some conventions for using Git. We are going to talk this a little bit later to show you different type of flow. But this introductory article lists a few different Git workflow, branching workflow. So if you are going to work in a team, with a team or for a company, they may have a different requirement or rules for you how to submit or push or review your work. So there are different type of branching, convention, and workflow. Here we just list a few that is very popular ones, like Git flow or like GitHub flow. And the last one is quite useful because I think some of you haven't already familiar with Git, but what I'm going to just show you how it works in a moment. But some of you have already know what Git is. So one of the things that you definitely have encountered is when you're using Git is that you think, okay, I'm doing something wrong. I commit something. I want to take it back. I want to undo the things I just do. If you haven't tried Git already, just imagine you have an editor that you can input some text in it. But after sometimes you just type in something wrong. You have some typo, or you don't have typo, but you just want to refresh the things you just written, or you just regret what you were written. You want to undo something. However, you'll find that it is very difficult to undo in Git because Git is designed to be incremental, to be immutable, sort of immutable. Everything is logged or submitted into the Git branching tree, then it will remain there. Sort of like the blockchain. You cannot erase the history in the blockchain. In fact, the Git tree has some similarity to the blockchain. If you search things like Git vs blockchain, you probably will search a lot, some of the terminology right here. Git is not exactly a blockchain, but they all have similar. Here, they are all the Merkle tree as their fundamental data structure. So there has some similarity that everything submitted in the blockchain or in the Git tree, then you cannot easily take it back. So this website gives you a lot of different techniques to undo the things you just committed in different situations. Some of them are just works for the situations, and some of them are not exactly undo, but at least you can go back because everything has been submitted. So every history is kept in a Git. So you can go back time to, at least you can go back time to the time that you haven't do the things. So, but the history remains. Sometimes that's the best. That is the best thing you can have. Okay, so let's begin with showing some basic operations that typically can be done with Git. Let me open my GitHub. Some people confuse with GitHub and Git. In fact, Git is a technology developed by Linus, the inventor of the Linux operating system. So he developed a version control system, Git. So that is a software and a protocol. However, GitHub is a website currently owned by, I think, owned by Microsoft. So GitHub uses Git, but other websites like GitLab, there's another like GitLab. GitLab, this one is another website called GitLab. Use Git as well, and you don't need a website. You can just run the Git on your local machine as well. But I think GitHub is still the most popular one, so I'm going to demonstrate things using GitHub. So how to create a Git repo or the repository? That's shorthand of repository. A repository is like a unit of the Git for controlling a folder of subcode or of source code. So if you are not familiar with what repository is, you are just thinking it is a folder contains a project. So if you have using something like a Visual Studio or other IDE, it is kind of like just a project. Or it is just a project for doing things. However, sometimes we need a few repos to work with each other. And sometimes a repo contains a lot of different sub-projects. However, just as I said, a repository is just a unit of the storage of the things that controlled by the Git. Also, there are many ways to create a new Git repository. One way to do that is, let me just make a new directory right here. I'll just call new repo. then I can use git init here to initialize this empty Git repository. That's one way you can do it at your local computer without any website. However, just like I said, I'm showing you a very common workflow that is create something on the GitHub. So let the GitHub to manage the repo for you, and you can easily share this repository to other users and collaborate it. So the thing you do here is using a new here and type the repository name. Let me just call it a new test repo. And you can give some optional description here and make it public or private. And if you wish, you can add a README file into it. And here, you can add something like gitignore. What does the gitignore file do? It ignores some files that is temporary or something like a binary that you don't want to track by the Git, because most of the time we only want the Git to track the source files, or mostly like the text file or source code. We don't want it to track something like the compiled executable or objective files or maybe dataset, because some of them are too large and some of them are like platform dependent. Because sometimes we like the C or Rust, we want to compile something, and because we can keep the source code to make it portable, but on different machines we want to compile the code on that machine so that the executable can be executed efficiently on that machine. So we don't want the executable on our source code tree. So we want to ignore certain files. Then we can use this file to release the files that we don't want to track. And in typical Python development, we can choose the gitignore template Python to initialize our repository. Then we need to choose a nice license. We don't need to choose a license. Let me correct myself. But you can choose a license. And I think it is a good idea to choose a license. Most of the time, you probably want to choose MIT or Apache or GNU. What's the difference between all these licenses? The GNU is a license that is we call a copyleft. The major difference between GNU and other license is that when people use your source code in part of their software, then all of their software has to be open source. So to begin, if you use GNU or all of these most of these licenses, then your source code is considered as an open source code, so that it allows people to share the source code. But GNU take it to a more extreme level. If they use your source code inside their code, the whole source code has to be open source too, and under the GNU generalized public license as well. Also, that's the GNU, one of the special things about the GNU license. To simply speak, it is not easy to make commercial software with GNU license, because when people want to use this source code in their commercial product, they will have to open the source. So there are no secret in their software. It is not that easy for business. So people generally avoid GNU license if they are planning to do some commercial software. There's some loophole and some way to work around, because there's also a LGPL library. I'm not sure here we have it. There is also a library called the LGPL, which means you only need to release the part that you modify the original source, because you are using some people use your source code as a library. So when they release the code, they have to also release the source code of your code and their modifications. But they can keep some part of the clean source code secret. Okay, and there are other licenses like MIT and Apache. The MIT license and the BSD license are mostly extremely free. People can use your code in mostly any way and without restriction, even in the business commercial software. But they have different ways to consider the when doing commercial things. Apache has considered more about it. And I think MIT still need to, at least all of this still need to contribute the credit, give a credit to your contribution. However, there is something called the CC0, or it's most likely a public domain, which means if you are giving this code the CC0, Creative Commons 0, then people can take it and mention nothing about you, because this one is just like a public domain. Public domain means people can use it any way they want, and they do not need to give you the credit. Or sometimes you can put the code in this sense, because sometimes we are just writing some trash like hello world or something. When I write something like hello world or like the for loop to just print out the Christmas tree, I don't even want to put the license like an MIT license on it. I can choose to have non-license with it, but kind of like the Zen of Python or the philosophy of Python, explicit is better than implicit. So in that case, I probably will just choose the Creative 0 or like MIT is good enough, because MIT is free enough, I believe. And the BSD, to my opinion, MIT BSD are pretty similar. I don't know about the Mozilla and the other license, but there are some websites you can check the differences, major difference between them. Or that, like, let me just do it. Here are just some answering, but okay, that's good enough. I remember there's a website dedicated for comparing the license. Okay, but I cannot find it right now. So just search and you can see some of the difference. Okay, let's go back to the GitHub here. Let me choose MIT license. So most of the time, I think MIT is good enough for because these are just doing most of it for demonstration or teaching. So MIT is usually just fine for me. Besides, this repo is a demo repo, so it's more likely to be a mostly empty repo. So let me just create this repository. So after I create a repository, I automatically get the gitignore, license, and the README files. I can actually edit the README files here, like I can just put and commit a change on the website. So this here demonstrate what does it commit means. I actually there's a part called a commit message, and who committed, and which branch it is committed to. So let me commit a change here. Okay, so you can see that we have only one branch, main branch here. The main branch is used to call the master branch. However, because the master is usually compared to the slave, so we call a master or slave thing, like a server client, master slave. So when we call a branch master, it's sort of like people have some problem with it in the sense of political correctness. So after a while, like I think like 5, maybe 10 years ago, people want to change the master to the main. And after a while, it becomes the default for GitHub. So when you initialize a default branch in GitHub, it will have a main branch, not the master branch. If you look at the article here, the 4 branching workflows in Git, it still has the name master. So you have to update this article and replace every master with main if you are using a GitHub or another major project. People has changed the master branch into the new name called the main branch. In GitHub, there's a tab here called Insight. You can visualize the branch here and the commit history. So let me put here the network. So you can see we have a small tree right here. The left dot is the initial one. So you can see here. Here is the initial one. And you can see what has happening to this commit because we are creating all of these files right here. The gitignore, this file is gitignore, and maybe you can see a little bit here. You can see a README and maybe a license here. And here the other dot is the current status of the file, which is that we update the README. If you click into it, you can see the change here. We add a new line just right here. This is a README file. That's it. And we have 2 different commits in the main branch. And currently the main branch point at this commit. And we can get this file. If you go back to the code here, it will show you how to clone this source code based to your repo. So let me do it this way. I mean, you can use either HTTPS or SSH or other like GitHub client, but currently I'm not teaching GitHub. We are discussing the Git itself, so I'm using Git. So the command I'm going to use is git clone, so that I'm going to clone the whole source code files into my into the folder of new test repo. So everything has been cloned right here. And now let me make some change. So let me using the touch, which we has already talked about this command. This is a new file. Let me just call it a new file right here. If I use git status, you can see that it tells us we have one new file that is on track. It is not tracked by the version control yet. So we have to add it into the version control. So git add the new file. So this file is in the version control. Now if we use the git status, then you can see that it is under the tracking, and because it tracked, we see that it is a new file that has not committed yet. So we can commit this thing, and if we commit here, because this is a new file, it is going to be commit. If you want to commit every change, you can use the -a, which means commit everything, commit all. A stands for all. Let me just use commit A here. Then you are going to, okay, I haven't. Oh, this, okay, I haven't set the username and email yet. So user email, let me put my user email here. And put my username like GW. So let me commit it again. So after you commit, you are going to take to a text editor. It depends on your system, but on Ubuntu, the default editor is Nano. You can set it to be theme or other editors you want, but the default is Nano. Let me just put a message here. Okay, then I exit and save the modified thing. Then the file has been commit. We have a new file here, but all the things we have done here right now is just for local change. The modification is not reflected to here yet. We still has no new file. We need to do one thing called the push to push our modification to the remote website. So after we do the push here, let me reload this page. You can see that we already got one new file, and you can see that we can actually see the history. Okay, 3 commits here. You can see that here is our commit history. So at the beginning, we have an initial commit, update the README, and add a new file. And at each step, it has a hash code. The hash code is actually longer, but it is not human friendly. So it gives a short suffix. Actually, the initial segment of the hash, so that you can easily check. Because if it is getting longer, people cannot memorize a string without any meaning that long. So we give a shorthand of a shorter form of the hash code. This hash code indicates that every file, it is computed by the hash code of every file at this moment. So it indicates that this thing is immutable. I mean, you cannot change anything back, and kind of like a signature, like a blockchain, so that you cannot change anything. So basic idea is that we can only add things. We can also create some new branch, like let me check a new branch. Check out to a new branch called test 1. So we switch to a new branch. In this branch, let me edit this new file to add something. In new if I show the GIT status, and I will see that the new file has been modified, then I can git commit. I can commit everything, or I can specify the files that I want to commit, which is the new file. And without you invoking the editor, I can type the message in the command line. Let me just call it modification in test 1. I think this command is more popular. I mean, people use it more frequently. But otherwise, you have to invoke a new editor. But in this case, we can just do it in one line, and everything has been done. But again, this modification is still local. If we want to reflect this to the website, we have to push it. But you will see that because this new branch has not set the website yet, because we already know, because we have cloned the things from the GitHub. So the main branching has been coupled or related with the GitHub branching. Its main branch, but this one is newly created. This branch in test 1 is newly created, so we don't yet know what the upstream is. So we'll have to set by using this command. You don't have to remember this command, because every time you do the git push, it will tell you, and most of the time this is exactly what you need to do, unless you want to track the test 1 branch on for the other website like GitLab or other place. So you should set it to another place. Otherwise, it is just what you want. So I just set the upstream to the GitHub and push it. So next time I don't have to use the set upstream origin things. I just push it. So let me just modify it further. Yes, it is a new file. Okay. Then we commit. This time I'm using -a and this message. I'm just giving a dummy message right here, and I push it, and it is going to the remote GitHub repo. So you can imagine maybe we want to do some debugging or trying some new feature. So we have a new branch, but sometimes we want to go back to the original one. So I simply check out the main. You can see that I have already switched to the main, and and you can see that the new file is going back to an empty file here. If I switch to the test one, then the new file is going to be this guy. So got everything we want here. And you can check the whole things here. So the main is still the same, but we have a new branch right here. And it has some modifications. Because the test one is modified from the original one. So the history combined with the old history of the main. But suppose we go to the main branching and do some modification. Maybe I'm doing something else. There is one thing that is more difficult, more advanced to do is the merging conflict. But currently I'm going to avoid these things. There are some tutorials about how to solve the conflicting in Git merge. There's another tutorial. You can search for it. But today's primary focus is on the branching, the concept of branching. So I kind of avoid to make things to have some confliction. So let me create a new file using another way. Let me just echo hello into hello. So we have a new file, and if you use git status, you may see that we have an untracked file again, and we add this file and commit. Let me check. I'm in the main. Yes, I'm in the main. That's what I want. Let me commit the hello with the message hello, and let me push it. Okay, so go back to the GitHub here. You can see that there's not this new hello push does not appear here because it is a modification on the original main branch. So the hello is right here. So if we go to the insight and see a network, you can have a more clear visualization. At the beginning, we have an initial. Here, and then we got I think we add a new file here and do some modification. Maybe okay, I added a README and add a new file here at my computer, and I create a new branch test1 and do some modifications. And when I go back to the main branch, I made a new file. So you can see we can visualize the whole development in this network graph. So what if I want to combine these two modifications? Say this one is a new feature or some bug fixing, and I have done it, and my colleagues or myself maybe has already worked on the main branch and has some other works, some development, but I want to combine these two things together to have this new feature and the update development together. How should I do it? In here, we can do okay. Where am I? Git status. Okay, I'm in the main here. So I can merge the test1 here. Okay. Then I have already merged it here. So you can see here, I am still in the main. I'm still in the main branch, but my new files has been modified to have, it's not empty. And I also have the hello files here. And if you go here to see a network, oh, I haven't pushed it. If you go to the network to see here, you can see that this modification has been merged into the main. Okay, so that's pretty much a simple, kind of dummy, easy workflow. Just in case you haven't tried Git before. Because if you haven't used Git before, the following exercise will make less sense, very little sense to you. But if you have already used the Git, you probably just use some basic operations. So the following introduction to the branching concept of the Git will enlighten you and let you know what exactly has done underneath the Git. Okay, one thing I have to mention is that the subcommand of Git is not very logical. One thing is that note that we use git checkout -b to create a new branch. So it is checkout, but we are creating a new branch right here. Instead of using that was still okay, but you will see there are a lot of command is not that well organized, or you have to realize there's some history for the naming of these subcommands. Okay, but just keep this in mind. Let's go to the exercise here. The learning branching here. So welcome to the learning Git branching. It will have some introduction, but let's start with the first one. Okay, it has some introduction right here. Git is Git commit is since, but basically the first lesson 1 is tell you what is a Git commit is. Basically, we have done some modification already, and we can use git commit to commit a new node in a tree. So the C0, instead of using a hash, it uses something more readable like C0, C1, C2. But in real life, in practice, you should replace this C0, C1, C2 into the hash you have already seen. Okay, so the first lesson is pretty easy. Use git commit to add a new commit into the branching tree, into a current branching. Okay. So for these exercises, it is going to give you a goal to reach. So we want to do some operations, git operations, to make the trees look like this one. Now this one is, currently we have one C0 commit and C1 commit. We want to make 2 more commits after it. We simply do git commit, and we get a new one. Git commit, we got the thing we want. That's easy. That is easy. So do not feel intimidated when you see that, okay, we have so many exercises to do. A lot of them are pretty easy. They are just helping you to understand the basic concept. However, they do have something more challenge. You are going to, I think like 5, maybe 10 exercise is sort of a challenge, but you don't have to do it perfect. And I believe most of you can finish it. So just try it. If you have any question, you can still ask the TA, me, or to your classmates. Okay. Another thing about Git branch is the branching is very cheap. That's one of the benefits of using Git. If you do it like a more traditional way to do things, you probably want to copy or back up a version frequently. So you back up one thing and do a modification, and if it doesn't work, you extract or recover things from backup. That's something you do. But doing backup is quite expensive. You have to copy a lot of things, especially if your repo is getting larger and larger. But Git branch is very cheap. You can consider it is almost free. It is not free, but in most of the cases, it can be considered almost free. So you can see that in my demonstration, when I switch between the test1 branch and the main branch, it is almost effortless. And I can modify things in test1 and save and go back to the main. And everything I have modified in the test1 is referred, and I don't have to worry about everything is disappeared because they are there. After I switch back to the test1 branch, everything will be right there. So it is useful, kind of like a backup storage, but it is very cheap. So in the Git, it encourages you to create a lot of different branch. So how do we create a branch? One way to do that is like check out -b. And the other way to do that is using the command git branch thing. So after I use the git branch new image, you will see that we have a new image, a new branch here. A branch, although the branch may look like, the branch comes from the words related to a tree, like just a different fork, a different branch. But it is more like a tag or a mark or a label. When you do the Git, you just imagine that a branch is simply a label that is movable. The branching tree itself is immutable. You can add something. Sort of you can incrementally add something, but you cannot modify each tag, each node. However, you can move the labels around it. There are several different kinds of labels. One of the kind is the branch. So branch is simply just a label. So So by this imagination, it will be more handy if you try to do so. So for one thing, if you already have a main branch right here, have say a test one branch right here, you have two branch already. Or say you have two branch, you can absolutely swap this branch to make the test one to become the main branch, and the main branch become the original test one branch. You can swap them because they are just some labels, the movable labels. Okay, so you can see that we don't have a new tree, new branch right here. We just have a new image that point right here. After we created a new image branch here, we can do a commit, because currently we are still on the main branch. So after we do the commit, the main branch is going to move forward to a new commit. However, the new image branch is still stay at the original position or the original location. It doesn't move. Kind of like the situation we did for the test one and the main. We did some commit on the test one branch, but the main branch still stay at the original position. And we can do the checkout first and do the commit. By using a checkout, we can switch the current repo, current branching, into another one, and we can work on that branching. In Git version 2.23, there's a new command called git switch. It will eventually replace git checkout. Because checkout has, just like I said, it can do a lot of different things. So the switch is more easier. But in the lesson here, we can still use the checkout. And it introduced the -b here. So let's see our goal here. We want to create a new bug fix branch and switch the branch to this new branch. So the correct way to do that is git checkout. Okay, I see I didn't. Okay, let me move this a little bit upward so that you can see here. Okay, git check out the -b bug fix. So we create a new branch and switch it to it. Okay, we have done this, and let's do the next one. Let's do the branch and the merge. So suppose we already have a bug fix branch and a main branch here. We want to merge the bug fix branch into the main branch. So this is something we have done on the main here layer. Okay, so it has some explanations here right here. So let's see what we want to achieve in this exercise. So first of all, we will have a C3 here, but before that, or I will have a C2. So first git checkout -b bug fix. Let's first commit a new commitment C2, and when let's check out to a main branch and commit a new commit C3, and then we want to merge the bug fix here. But note that because C3 is immutable, every node is immutable. So when we say merge, we didn't change the content of C3. In fact, we create a new node called C4. That is combination between the C2 and the C3. So let's do it. Merge bug fix. Okay. So that's the concept behind the branch. So one important point is every node is immutable. You cannot change the content. And every branch is in fact just a pointer or label. Let me just call it pointer. Because if I call it tag, it is not entirely true because there's also another thing called a tag. And the tag is kind of like a pointer. And there is also a thing called a head. Head is also, you can consider as a point. A label that point to a thing. Okay, let's move to the next one. Git rebase. So rebase is not another action. So let's say we have a thing like a main and a bug fix here. We want to rebase main. What does it mean by rebase main? Note we are currently at the bug fix branch. So what does it mean by rebase? Rebase is kind of like merge, but sort of like merge a bug fix into main, except it is not. Let's do it. You can see that we create a new, we kind of move this change here from C1 to C3. We have make some difference, some change here. The rebase is to move this change and let it be the change, apply it to C2. So this is rebase. This one is rebase. So you can see that the original branch bug fix has it was still there. It just we point our bug fix label to here after, sort of like after the branch of main. So we can then do a rebase bug fix here. So one thing here is it kind of like merge, except it still remains as a structure of a tree, because when we do a merge, it will have something like it is not exactly a loop, but let's go here. You can see it was sort of like, if we ignore the arrows, the directions, it is sort of create a loop. But in any way, it is not exactly a tree. A tree will have no loop at all. But here, if you use rebase, it is more like still keep it a structure kind of like a tree. It's more clean. However, it may be a little bit difficult to see the fact that this guy, I mean from C2 to C3 plus, is the change from C1 to C3, because I mean there's no connection between C3 to this node. On the contrast, it is quite easy to see that this guy and this guy merge into this commit. So that's the main difference. There are some benefits of the merge and some benefits of the rebase. So it heavily depends on the opinion. Okay, by the way, we have a Slido. So if you have any question, you can just ask on a Slido, and I will, when I see it, I will try to answer the question. Okay, so rebase, you can consider rebase is another kind of merge, but it is not merge, and it doesn't call, we doesn't call it merge, we call it rebase. I think we probably are going to get it why I say the name is not very logical, because we have a lot of similar things, but they do call it differently, and you are going to see a lot of things like that. And another thing is that, I mean, you can see that this modification is after this one. This modification is after this one. They have a order who did it first and who did the second, and then just merge them together. Okay, then in this exercise, in this level, we are going to. I didn't read the description. I just see the things we want to achieve, and I do it. I just solve it to make it like the drawing on the right, like the diagram on the right. So first of all, we need to have another branch. Okay, let's have a bug fix, and let's have a C2. Let's check out to the main, and commit again to have a C3. Then we go back to the bug fix. Then rebase to main. That's all. Okay, next, in the next few levels, we probably are going to navigate, move around in Git. Ahead is also another pointer, kind of like the branch, but it is not branch. Ahead is something that you are currently working on. It can be considered the start. Remember, we have the main, and if we check out to the main, it will have a star. It's most likely the star, except sometimes you can detach this star from a branch and just move around without changing any branch. So normally head points to a branch name, but sometimes you can detach it. So see this command. We check out C1, we can simply check out C1. You may see that why do we even need to check out C1? Because we have already on C1. But by doing so, you are detached the head with the main. And when we check out the main, it will attach the head back to the main again. Okay. So we can use the check directly to the hash, like here, to detach the head. Like you can see here, when we check C1, check out C1, then we actually detach the head. So we simply C4. We simply check out C4. And it's done. Okay. So a lot of levels are quite easy and straightforward. Okay, for the next levels, we are doing more navigation. One of them is the relative rifts using a head notion, a which notion here. So most of the C0, C1, C2 is a shorthand of the more full-length hash, kind of like this one. A lot of things you can do is to shorten them to be a short name, as long as they are unique. But in this exercise, we're calling it C0, C1, C2. So what does this hash mean? This means one commit before it, like a parent commit, the upward commit. You will see that in action. And if you want to jump back like 2 or 3, you can use the tilde number to do so. So for example, let's check out main head here. This means C1, but we don't need to type C1 because although C1 is quite easy to type, but in general, it will be a long hash name. Even if you can type a short hash code, but still you need to look at, I don't think you can memorize it, but it is very easy to memorize that it's just one commit upward to the main branch right here. So we can check out the main head here, and we can check out our head to this place. So we can check out to C3 already, we can check out to head before it, we can check out to back again, and then we can, because the head is already right here, we can check it to the one before it. So let's do it. You can see that it moves upwards. So in this case, we can, although we have currently we are at bug fix, it doesn't matter where we are. We can git check out bug fix head here, and we can go to the C3. And the tilde operator can jump multiple steps in one line. So for here, head tilde 4 means we go back 1, 2, 3, 4 to C0. So you can see that it jump just in one option, in one action. Another way to do that is to do the branch forcing. We can force our branch to a place. So in this case, we can. It is a way to move a branch pointer to ask it to point to another place. So for example, we want to move the main to the head tilde 3, 1, 2, 3. So we can move the main here. This is one restriction of this command, is you cannot move the branch if you are currently in. So see that we are currently in the bug fix, so we can move main. But because we are in the bug fix branch right here, the star is right here, it cannot be moved. It makes sense because you are already in there. So if you use this one to move to layer, it's sort of can be confused. Do you want to move it and keep the current files, or just want to check out back to that commit? So it kind of makes sense, but also it makes things more complicated, because also you can see that although it is a branch command, it actually moves things to another place. Sort of like a navigation, but navigation for the branch labeling, not for the head. In fact, the concepts are pretty easy. They just move things around. Sometimes you move the head, sometimes you move the branch, sometimes you will probably move a tag or things. Just that. And we already have a unified method to determine the location, like the head or tilde, or just give the hash name or give the branch name. So maybe we probably just we only need a command called move or modify. That will serve a lot of things well, but instead, probably because of the historical reasons, we have a bunch of branch, checkout, merge, rebase. A lot of them are doing similar things. It's sort of confused to each other. Okay, so let's finish the next level. So what we want to do is to move the head to C1 and move bug fix to C0 and the main to C6. Okay, main to C6. So and we move bug fix to where? To C0. And move head to C1. Okay, that's it. Okay, for the next several levels, we're probably going to reversing the change in Git. Just kind of like what we said, it is difficult to do undo in Git. But there are several ways to do that. It is especially helpful for you if you understand how the undo works. So we are going to see it. If you are still not yet familiar with the Git branching concept, you can refer to the website that we just pointed out and check out which situation you are in and use that command directly. But right now we are going to discuss the concept behind this reversing change things. There are two commands dedicated for reversing things, but you may see that we can still, we can simply check out the previous commit and move our branch back then by using branch-f. It kind of mimics the undo. So even though you don't know what the git reset or git revert is, you can sort of reverse the change already by using the combination of the branch-f and the checkout. But why do we need reset and revert? Because they are still quite useful and important. Let's see what it does. So for reset, git reset, it take argument. The argument is a commit checkpoint, a commit. So in here, if we go back one commit, and currently we are at head, so we simply git reset head tilde 1. It's sort of like the branch -f, except it works on the current branch. So you can see that it's pretty similar to the branch -f, except it works on current branch. So you don't have to specify which branch you need to move. And unlike the branch -f, you can work and you can only work on the current branch. So that's a different. Also you can git reset head tilde 1. It is very similar to the git branch -f. It's very similar. It just has some restriction you have to understand about it. But they have very different name, but doing very similar things. The only difference is it works on the current branch, and the branch -f work on all branches except the current branch. So what does git revert do? The git revert in fact create a counter effect on previous actions, on previous commit. So instead of saying we are going back to C1, we say that we revert head, we revert C2 here, we revert C2 here. So if you see, this is another confusion. Although revert and reset sort of have the same meaning to go back to C1, but for the reset, you are going to say git reset C1 because it is moving the label to back here. But revert, you have to say git revert head or git revert C2. You can see that we actually create a new commit, but it undo the change. So why do we even need this one? Why don't we just use the reset or something like the branch -f and check out combinations? Isn't that even better? It is because when you working with other people, when you are working with other people, even if you refer to the C1, people are probably working on C2 already. So it makes it difficult for them to do the merge or other things. Because if they merge it with the C1, if we have a C3 right here, and if it merges with the C1, the C2 will be merged, the change of C2 will be merged into it also. But if you have this counter commit, and if someone working at here, like C2 and get a C3, or if they start from C1 and get some C3, C4, and if they merge with this C2 prime, this undo change is going to be merged into the thing. So it's mostly for the working, and also sometimes it is important to have a record of things, even if that thing is something you have regret or if you has done wrong. So depends on your philosophy. Sometimes this one is much better, but if you mostly you work on your own, and it's just like if you take your Git like just like a playground or like a draft of your source code, then I think using a reset is totally fine. And you still have the record of getting a dead commit, because if you reset, you're going to C1 and the next commit will grow up from C1. So this one has no one point to it. So you still got this commit. It just nothing is pointing to it. So that is still okay. You still got the log. You have done something. It just probably the reset things does not record it yet in the, I mean at least not in the branching structure itself. Okay, so let's do some exercise to complete this level. It refers the most recent commit on both local and the pushed. You will refer 2 commits total. Okay. So we want to refer 2 things. The local. Okay. So the local want to be reset. Because we are currently in local, so we reset to C1. Okay. And we revert. We first check out to pushed. Okay, so we are done. You can also refer head, which should be better, but I just happen to use the C2. Okay, for the next level, we are going to use a very, very powerful command called the cherry pick. Until now, you might already have some confidence about manipulating the tree itself. If you are feeling so, you're pretty right, because if you understand how the branching, the git tree works, by the combination of like the git reset, git checkout, git branch, -f, you can build up any tree you want almost. Almostly, because we haven't talked about the some of like the remote things, and we know how so there are some clone or poor things. So there are still something more, but most of the case you can kind of rearrange your tree to your need. You can undo things to anything you want. Almost anything you want. However, there's some more command that on top of this command to make things even easier. One of them is cherry pick. There's another one. We'll show you just in a moment. But cherry pick is already a very powerful. You can kind of doing the surgery on a new branch. So suppose we already have a lot of different commits. We want to mix and match these commits together in certain order. Or maybe we want to, for some reason, we want to apply the change 1 first, change A first, and change B second, change C the third. We can do that. So we are doing a surgery on the, we can use a cherry pick to construct a new sort of new fork. We don't use the word branch here because branch is already taken. But just say we create a new fork. Although the fork is not proper still, because it's also not good, because in the realm of GitHub, the fork means we fork a repo. But anyway, let me call it a fork, because we are not going to talk about the fork in the GitHub repo. When I say a fork meaning I'm create a new path attached to the tree. Okay, so when I use cherry pick, I can pick up a few different commits and put them together to form a new path, to form a new fork on it. So for example, currently we are on a main, right? So if we cherry pick C2, C2 is this guy, and C4 and is this guy, then we can grow up this fork, grow up this branch with 2 more nodes. So we pick C2 and C4 and pick them right here. So we simply ignore C3. Possibly, I mean, one of the use cases is that when you're doing debug things, you probably add some like print or some debug code inside it. Though we usually say that there are some more elegant way to do the debug, like using the debugger or using a trace or using a profile or other things. But the truth is, when you have a bug, it is difficult to find it out and to fix it. So when we have a bug, we use any ugly way to figure out what the bug is and to fix it. So chances are you, at some commit, you add some print statement inside the file, and you don't want to keep these ugly things or showing a lot of different unwanted log. You sort of kind of embrace yourself because they are too detailed. But sometimes you just don't know where is the bug. You kind of demonstrate, so you add a lot of log function in it, and you don't want it when you merge back to your main branch. So you simply pick the one that you can isolate those debug function right here and just pick those things that actually fix the bug. Okay, so let's do the next level. So what we want to do is to construct we bug fix here side here, and another is here. We want to construct a new branch, not a new branch, extend the main branch here. So here's the main branch. So we simply git cherry pick C3, C4, and C7. Okay, then that's it. We're done. So the other one is interactive rebase. So git cherry pick is great. But there is something that is even more powerful, which we call the git interactive rebase. So it is just calling the rebase with an option -i here. And it will invoke an editor. In our case, it's probably the nano there. Or sometimes a theme. So we can use that to pick, to modify the branch we need and put them together. However, in this exercise, we're kind of emulated the result, like pick this one, and pick this one. Maybe we can arrange this one, arrange like this one. We can do things like this one, and then confirm. Okay, that's it. So we do the thing. So we need C3 over here. We need to rebase our main on over here, and we only need to pick C3, C5, and C4. So C3, C5, and C4. Let's confirm here. Okay, that's it. We can also use the cherry pick, but we just respect the description of the level. So we use the rebase-i. Okay, so here they just explain something like I explained before. Sometimes you do the bug fix and have a lot of like debugging print statement. You want to remove them simply. We can use this rebase-i or cherry pick to pick up the clean commit and organize them together. Okay, so I think we already get most of the things. I want to show, go back here. How do I go back? Let me check. I want to show the levels and go to the remote part. Show commands. Okay, let me. Levels, probably levels. Okay, it's just simply as levels. So I have already done a lot of things, but the laters are more advanced ones, thing. So you can try all this like 8 things. I have already shown you how to do the thing. The first several are quite easier, but yeah, I don't remember, but some of them are a little bit challenging. You need to be focused on this, but that all of them are not too difficult. But now I'm going to show you a view of the levels for the remote, Git remote, because this is the part that things get ugly, and because when you are working with other people, you are going to be afraid that you erase the whole history on the server. And in fact, you probably can do it. So you need to be quite clearly understand the concept of remote repo and your local one. But by using the command that we presented before, in fact, you can do absolutely anything on your local Git, on your Git tree or branches, and there are commands. So if you are only work with it by yourself and you only want to use Git as a very convenient version control tools and or the storage things, you can manipulate any way you like using the method before we are talking about. And at here, you are going to learn a few ways to actually force the remote repo to be an exact copy of your local repo. You can do that. You can actually do that. But even better, you can learn things to cooperate with other people because you understand the concept of the remote Git tree and the local Git tree. So first of all, just like we demonstrated at the beginning, we can clone a repo from a remote. So in this setting, suppose we have a remote repo and we can clone it. So use this to simulate the operations here. So the first command is quite easy. We clone it. We simply git clone. Then we are done. Of course, in the real world, the command is a little bit more complicated. You need to actually give the URL, and by using push, like we showed before, you have to set the origin. And when you do the first commit in a system, you have to set up the username, user email, things like that. But in this levels, we're going to work through the core concept of what the remote branch and local branch is. The first thing about the major difference about the remote branch and local branch is that you cannot easily manipulate the labels, or I mean the branch names on the remote side. You have to follow a more restrict rules to do so. Unless you do some nuclear weapons to do that, but in most cases it is not that easy to do so, and you have to know the relation between the remote branch and the local branch. So we have, I mean, when we clone the remote branch, we actually set a relationship between some of the local branch and some of the remote branch. So that's why we have to set origin when we create a new branch. Back at the beginning of the class, we create a new branch called test1, and when we push it, the Git refuses to do so. It asks us to explicit to set the origin of this repo. That's the reason, because every branch of the local branch, if you want to push it to the remote, it will have a corresponding branch on the remote. And also, on the local, you will have a special branch that is directly represent the remote branch, which we call the origin main, So it has a special name, origin main. This one is directly corresponded to the remote branch label. except sometimes you still need networks, right? Because if somebody already changed the origin and you haven't pulled things, this will stay at the original location. It cannot have the information without passing information through the network. Okay, so don't worry about it. We'll walk through everything. You just remember there are a lot of different things. So there's one special branch called the special property called the some special branch called the O-man. The O is usually called the ORIG, origin man, but we just call it O-man. So O-man and man are different, and any of them are not exactly the same as remote man, but all of them are closely related. Just remember we have different things. So the O is usually called the origin, or ORIG, or origin, or ORIGIN, the full name like this one. So let's check out a remote branch. So we can actually check out O-man and commit. As you can see that if we check out into this origin man and we commit, let me do it again. Try to watch this star. So at the beginning, the star disappeared. So when we check out to O-man, it doesn't have, the star does not move to the O-man. The head is not bind to the O-man. It actually bind to the commit the O-man is pointing at. It is because we cannot directly manipulate this O-man. This O-man is just information, a shadow of the remote man. Now this one, I think that's a pretty good description. It is just a shadow of a remote man. So although when the man moves, it doesn't necessarily to move because we have to do some operation like pulling, or fetching, but it is the best we know about the remote man. So the updated information about the man for the remote repo. Okay, so here we want to git commit. We do a first do a git commit. Okay, we'll do a git commit. So we have a C3, and then we check out to O-man. So in fact, we just check out to C1. We can check out C1 as well. Then we git commit. So it just demonstrates, let you know what happened. Because O-man, although it is a branch, it is not the branch that we knew, the usual normal branch we knew. It is just a shadow of the foreign or the remote branch. So we use a git pull to. We haven't show that in our example, but usually we use git pull to pull the remote code to the local one, to update our local code. But the pull is a more complicated command. The more fundamental and more basic command is git fetch. It do one simple thing to update our information for the update our knowledge to the remote branch or to the remote repo. So suppose we already have this one, and you can see that on the remote, it has already pushed 2 more commit, but we don't know it yet. By using fetch, it will update this information. So the old man will update as the remote one. So this one is just git fetch. So if you just run the git fetch, old man should be exactly the same as the remote man. They should have the point to the same location. Except, of course, old man is at local, and the remote man is at remote repo. So that's exactly what the fetch do. And the pull, git pull, is in fact doing one fetch and doing the merge automatically. So let's just do the fetch. Okay, so let's see. The man is still right here, doesn't move. The bug fix is still right here and doesn't move. Except we want to update our knowledge to the remote repo. So we do the git fetch. So everything is done. So you cannot use like a git reset or git branch-f to move the old man, because they are just a shadow of the remote branch. You use a fetch to update them, and that's all you can do. So next level, we are going to use a pull, git pull. We probably use this more often. So after we use the git fetch, we probably want to update our local man to the original too. So we can do things like git rebase on it or git merge to it. There are two kind of workflow. Two major type of workflow. One is the rebase workflow. One is the merge workflow. The one that is probably more sort of traditional is fetch or then merge. We merge the man with old man. That is probably the most popular one. So there's a dedicated command called git pull. It does it automatically for you. It do the fetch first, and then do the merge. Merge everything in the original man into your man. So for example, right here, we have a C3 right here and a C2 right here. So we can do the fetch first to move the old man to here and merge. Okay, so we can do this in one move by just calling it git pull. They are exactly the same. So when you do the pull, it is simply just do the fetch first and then do a merge. So let's just finish this level because let's see what happens. Okay, we are C2 right here, and C4 and C3. Okay, so this is just one git pull. Now we are going to simulate more complicated situations for collaborations. In order to do that, this puzzle introduces a new fake command called the git fake teamwork. So when you do that, it will do some remote commit. Usually it is something like when we push something on it, it will have something similar to this effect. But without doing it explicitly, it kind of simulates someone has done this modification to the remote repo. So the fake teamwork is just some fake commit, and commit on the full. You can actually choose the branch you want to commit things. So this exercise helps us to understand how the teamwork do. So first of all, we have C1, C2, C3. C1, C2, C3. C1, C2, C3, and our own man is there, and we have a C5. Okay, there are several ways to do that, but I'm doing it more like the answers that this level expected. So first we use the git clone and git team fake teamwork on what? On man, but how many? 2 times. And then I commit 1 commit. We have C4, and we do the pull. Should we do a pull? No. Yeah, we do a pull. I can simply do a pull. Okay. Okay, so the next level we are doing push to push our work from local to the remote. So the pull and push is supposed to be pair with each other. They are on the opposite direction. So when we do push, what will happen? It will push our change to the remote, and also update because when we push the main branch in this case, because we are working on the main branch, so the remote main branch is going to change. So the original main, the old main, is also going to be more updated according to the situation on the remote. Okay, so here, this is quite simple. We simply commit and then we push. However, one of the main trouble is that sometimes we may have some branching tree that is sort of incompatible. Like the origin main, when you fetch it, the origin main and your main are on a different. I mean, the remote main and your main are on a different fork. That is very possible. So see, in this case, okay, it's more clear to see in this case. When we pull our fetch things from the remote, we only got the C1 commit. And after that, somebody has committed the C2. And we don't know that yet, and we do some modification on our code, and we got a C3. In this case, when we try to do a push, it cannot be done because the remote doesn't know how to actually push our main in here. Because one way to do that is we simply have the C3 right here and move this main to here. But this will be very difficult for your colleagues or your co-workers to handle it because this main is going to jump here and there. So a better way to do that is that we first resolve this situation so that our main is more compatible to the tree on the remote. So first we do the fetch and we do the rebase and we do the push. So see, after when we do the fetch, we got the remote C2 right here, and we can apply our work on the C2 instead of directly on C1. Then we get these things. And because originally, before we push our work, it has C0, C1, C2. So this tree is an extension of this guy because the first several are the same. So we simply append our modification to this path. So this can be done. But you have to do the fetch rebase first. There is also another way to do that is using merge. So we can use the pool directly, but I think it separated these two steps using fetch and merge to illustrate the idea, the difference between them. So what would happen if we do the fetch and merge? We will have a C2 right here. And we will have a C4 at the end of C3 and C2. This one is a new C4 node right here. And again, C4, C2, C1, C0 is compatible to C0, C1, C2 because we only have a C4 after this pass. So we can push that to the remote. So let's do it. So first we'll fetch it and get a C4 right here. And we'll push this thing back to here. So this one is going to be compatible and we can push it to the remote. So either way you can do that. So let me go back a little bit. The difference is that after this has been done, the tree is more clean. It's just one line, one linear line. You can see that this is just one linear line. There's nothing. This guy is not even right here, and even on the local, it is kind of hidden because no one is linked to it. So we simply have a simple line. But if we use merge, it will get more messy because we have something strangled to each other. It is still relatively easy because this is a simple case. But if you have more different branches, more codes, things will get a little bit messy. So that's the main difference. But this one keeps all the history. It just looks a little bit ugly. For at least for some people's aesthetic. For me, it's kind of this is okay. For me, this is okay. I can still read it. If I want, I can take this path. That's fine. But I mean, there are two type of people. One type of people like this merge things, and the other like the rebase things. So for the fetch merge things, we can use the git pull directly. For the fetch rebase things, we cannot. So it seems to be a little bit unfair. So you can actually use something like this one, git pull. But okay, I'm not using merge. I'm the type of person who like to use rebase. So you can give this option, dash rebase, to show that to tell the git that okay, I want you to do that in the rebase way, not in the merge way. In fact, you can do the config to change the behavior, default behavior of a pull, to make it to be rebase. So every time you do the pull, it will in fact do the git pull rebase. So there's some config allow you to do that. But just remember, there are two different ways to do that. You can have your preference, but just understand people may do things differently. So you can use pull rebase, then push it back to keep a simple straight line history. And we can use the regular git pull and push to update our change and push all the history to the remote. Okay, so let's do this level. Okay, so what do we want? Git clone. Okay, git fake teamwork 2, 3, 2, just 1. Git commit to get C3 and git pull dash rebase okay. Let me use fetch. Did I spell it wrong? I don't remember, but let me just use the fetch and rebase. Okay. Rebase and then do the push. Okay. Okay, what is the instruction here? Create another branch called the feature and push that to the remote. Also reset your main back to be in sync with the remote. Okay, so let's do this one. C2 feature Okay, so okay, just you can do these things to manipulate everything. Let me check the levels. Okay, we have already done everything right here, and okay, so let's do the next one here. So we want to merge in a feature branch. Also, I actually encourage you to at least do the remote things that I did it before, and I will do 1 or 2 levels more. But you can see that it actually describes a lot of common situations that you will encounter when you collaborate with others using Git. So in a common developer on a big project to do all their work on feature branch. So usually we do the things on feature branch, and we maybe sometimes we do the pull request so people can merge things by using by accepting the pull request. So we use the pull, rebase, and the git push. This is just a review of the things. This one is rebase and push. Okay, so let's try to do the next level. This level seems to be pretty hefty. Here is a hint here. So we have 3 feature branch, side 1, side 2, and side 3. We want to push each one of these features in order to the remote. Put the side 1 and side 2 and side 3. But the catch is the remote has been updated. So we will have to do something to make our local branch compatible to the remote before we can actually push it. So this one is quite intense. Okay, so first of all, we probably want to pull it to get our main here. Because it is compatible, so no matter you do the rebase pull or pull, it should be the same. Let me first check out main. Okay, so first of all, we move our main to that thing. And we want to kind of cherry pick things. C2, C3, C. But because we want the C3 to be here, side 1 to be here, side 2 to be here, So probably using the rebase will be more straightforward. So we first check out site 1 and the rebase on main. If all we want to do is to do this, to develop this path, we probably simply do the cherry pick and do the reset site 1 to here. But because this one is more intuitive and straightforward, so we do the rebase site 1 and rebase site 2. And let me do the git check out site 2 and git rebase site 1. And again, we do the check out site 3 and we do the check out site 2. Oh no, rebase site 2. So git check out site 3 and git rebase site 2. Okay. Then we check out main and merge to site 3. Then we do the push. So I'm going. I think I use too many operations. Maybe 3 or 4 more operations. But still do a job. Okay, I do way more. I do 7 more operations, so I can cut the command count a bit, and you can try it yourself because they definitely can be cut. Okay, so that's all. That's is all of our demonstration. I encourage you to try. I mean, the homework you have to do the homework for the main part, or just for the main part. You do all these things and several more. But I still encourage you not only to do the main part, you can also do a remote and finish all these things. It's not that difficult. It requires a little bit of thinking, like the one I did, but you don't have to do it in the minimal steps. Like what I did, I used 13 steps instead of just 6. That's totally fine. You still got a green check mark on the level. That works for me. But the thing is, you probably would understand. I mean, it's still better if you fulfill the requirement of the minimal steps to finish the work, to finish a level, to complete a level. But I think even if you can finish it with more commands than necessary, it's still good because you understand how to manipulate the git tree. It may not be the most efficient way to do so. There has some more efficient way, more shortcut to do that. But it shows that you have your toolbox to do everything you want. Just it may not be that efficient. But that's good enough because it's just, I mean, what's the difference between like 13 commands and the 6 command? Even if I do a lot of obvious mistake there, what's the difference between like 13 commands and the 6 commands? Because that's not like you are going to do it like every minute or every hours. you probably will do that like 2 or 3 times a day. And if you have to use like 6 commands or 13 commands, you probably will write them into a shell script and just run the shell script. Perhaps that's about it. But even if you have to type them, it's just like maybe like 4 or 5 seconds differences. I'm not saying that does not worth to improve yourself from 13 to 6 commands. It's just, I mean, certain commands is already a pretty good achievement. And for most time, it is quite practical and it's very useful in real world. And if you understand the concept behind the branch tree and the remote and the local repo, you probably has already beaten like 90% of people who claim to know how to use Git. But it still needs some experience to work with other workflow. Okay, so let's go to the post about the different workflow. Let me explain a little bit about the Git flow. So this one has some history. It is created by Vincent Jason in 2010. So it's already been like 14 years. So the basic idea is that we have a main branch that is more like the for the production code, meaning this is a code that you are going to actually run on your product. And you also keep another branch called the develop branch, which contains the code that is pretty complete, but still need a little bit testing or maybe some improvement before it can become the main branch or master branch. And when people trying to do the development, maybe there are 3 or 4, 5 software engineer or programmer, or maybe some other thing like designer to design web page style, things like that. They do not work directly on the develop branch. They are working on the feature branch. So for example, you want to add some functionality like, okay, I want to make this website support dark or light mode. Then you create a new feature branch called the feature something. And maybe you want to improve the style of the website. You probably call it a feature style improvement. Or maybe you wanted to add some user management, you call it a feature user management. And when you develop these features on this branch, feature branch, and then merge back to the develop branch when you're done. And in a lot of places, the merge back process is done by using the PR, pull request, by using a pull request. So someone will verify the code, review the code before it can be merged into a develop branch. Also, there are some hotfix branch, which is used to fix the bugs and some security issues. So these are called the hotfix branch. And this branch must be merged back to the master and the develop. So that makes sense because these emergency issues or bug or security holes could be exist in both production and develop. So you don't need to go through the develop first, then review, then approve, then go back to the main branch, because they are having some issues. Maybe they are kind of wasting, kind of spending money. People are, it costs money because of these bugs. So you need to make this hotfix go back to the main as soon as possible. And also, you don't want the development version has this bug too. So you are applying this to the development branch as well. After a while, you have some branches that are release branch, like 1.0, 1.1, 2.0, 2.1. So these one are the release branch. So this is some of the convention and the branches that is in the Git flow. Another is called the GitHub flow. It's sort of similar, but it has different. It still have a master, which is also the main branch and other branch. But other branches are different. So it has some rules about how do you create a new branch and do the commit. But here, everything is require a pull request here. And there are also GitLab flow, and it follows the following rules. And one flow, I haven't used it, but there are other workflow. So this is just a few flows that is you might encounter. Some workflows are kind of mixed match of these major like GitLab, GitHub, or Git flows. And you may encounter something totally new. But I think, nevertheless, when you understand the concept behind the Git branching, so you can adapt yourself to any kind of flow. And when the time comes to that you have to choose which flow you want to use, it all comes back to your personal preference and your experience. Because sometimes you may initially think, okay, I like this kind of workflow, but after time, like you collaborate with other people or debugging things or making some product, you will find out, okay, I understand more, I have more experience, so I kind of change my mind. I prefer my preference has changed. I like another workflow more, or I can modify this workflow into my needs. And also, there are different kind of product and different kind of project. Some of the workflow might more suitable for one, and some might suitable for others. Now, in this lecture, I'm going just the primary goal is just to make sure understand the help you understand how the branching works and what is the kind of the abstract structure beneath underlying the Git command. There's one big topic that I didn't cover here is the conflicts. There used to be I think there used to be a tutorial I use a lot, that for GitHub. But I think that is not available anymore, I believe. But there was GitHub has some training materials. One of them is to solve the merge conflict. And it also has some tasks and the puzzles that allow you to do. But currently, I think they have some security issues, so it doesn't exist anymore. We didn't cover that. But this document is quite a good entry point you can read off to find out how to solve the conflict. And another thing is that currently a lot of people using Visual Studio Code, and you can actually use Visual Studio Code for let me check one repo that, okay, maybe this one. So you can use this one to visualize the merge history, like this one, and use this one like to commit or to refresh, to commit to when you do some changes after the commit, you can actually do the push pull here without actually using the command line tools. That's totally fine. That's totally fine. But still, the concept is still there. You cannot get rid of the concept that we were doing for the homework, those concept in the puzzle. Another tool people like to use is the lazy git. I probably don't have it installed right here. A lot of people using lazy git. It is a text user interface for Git. So you can use this one. A lot of people like this one. Personally, I don't use that one, so I actually don't know how to use it. And even sometimes I use the Git Visual Studio Code here, especially for visualizing the history. But most of the time, I still prefer to do the like commit, push, pull things in the command line, and even solving the conflict. But it depends on you. And I think Visual Studio actually do a quite good job. So you don't have to familiar with the command line. You can use Visual Studio Code. It is quite okay, and or maybe you can use other UI because GitHub also provides some desktop version. Also, you can do it with a graphic user interface. That's totally okay. Especially, I mean, although you in the command line you can still visualize the graph, but nothing beat a graphic user interface when showing the the commit network. Because especially when the case is getting more complicated. So choose the tools you like, but just keep in mind that command line is still always be there, and the base concept is also the same. Okay, so that's all for today's content. Next week we are going to talk about Docker and some secure shell, SSH, mostly about the port forwarding and some basic concept about the secure shell. Okay, so see you next week.